Everybody, this is Mr. Loveless. I realized how to do the problem right after you left, and so I wanted to make sure I sent the video out how to do this. It turns out that my thinking was pretty close to what we had to do, but I just wanted to work through the problem. So this is number 65, I believe, on section 2.2, and the question was asking class how to do this, and I kind of forgot at the moment. So here's how you do it. The instructions say find the constant k so the line is tangent to the function. So what's happening here is I'm going to have some function here, and it looks like a rational function. It has some number over x. So you imagine this is going to have a vertical asymptote at x equals 0 here. And so we're going to have two sides of the function. It might look something like this. I don't know what it's going to actually look like, though, depending on what k is. So that's what f of x will look like depending on what k is. And I have this line negative 3/4 x plus 3. So I have a negative slope. So you imagine it's either going to be at 1 or 2 points. If I have a negative 3/4 slope, it means I go over 4 and then down 3. So I'm going to have this negative slope here with a 4 horizontal and a 3 negative. And so you can imagine if I were trying to find where this line is going to touch this graph so that it's tangent, you could see roughly where that might be, maybe here or here. All right? And so the algebra is going to determine which one it's going to be at if either of those will work. So what we want to happen is we want the slope, first of all, of f of x, the slope of f of x to equal the slope of the line, which is negative 3/4. So to find the slope of the line at any point, you need to find the derivative, f prime of x. Okay? And since this is k times x to the negative first, all I have to do is use a simple power rule. I'm going to have negative k divided by x to the second power. Okay? So that's the first thing. The other thing that needs to be true is, obviously this, of course, like I said, needs to be equal to negative 3/4. But that's only one condition. The only other condition that needs to be true is that these two function values have to be the same. That is, if I have this line that's tangent to this graph at some point here, it has to touch at the exact same moment as the function values. So I know that f of x and this line have to be the same at some point here. Okay? So I know that I could set them equal, so k over x has to be equal to negative 3/4 times x plus 3 at some x value. Okay? So the next step that we have to do is solve this function value equation for k. And once I find out what k is in this equation, I can plug it into this other relationship up here. This negative k over x squared is equal to negative 3/4. I will eventually take whatever I find for k over here and plug it in to that equation right there. So let's go ahead and keep solving this for k. I'm going to multiply both sides by x, and we're basically done. So I have negative 3/4 x to the second power plus 3x. And again, like I said, I'm going to plug in this value of k, which is this quadratic expression here, binomial. I'm going to plug it in for k up here. So then I'm going to have, you'll see negative 3/4 x to the second power plus 3x, all divided by x squared. You set that equal to negative 3/4. You'll find that conveniently these x's will divide out. Now I'll get negative 3/4 plus 3 over x will have to equal, I'm sorry, I think I forgot the sign change here. This would be negative here. So this would be positive 3/4 minus, and you see what happens when I'm not paying attention, minus 3x equals negative 3/4. Now, of course, you want to solve for x to find that x value where this is true. So if I subtract 3/4 from both sides, I'm going to negative 3 over x. And negative 3/4 minus 3 more fourths is negative 6/4. Now to solve, I will cross multiply. I get negative 12 equals negative 6x. And you'll find that the x value where this is true, where they have the same slope, is at x equals 2. And they'll also have the same y value at x equals 2. Supposedly, so now that I know what x is, I can plug it in and solve for what k actually is. Now k is equal to negative 3/4, and of course, we'll plug in 2 for x, plus 3 times 2, and then I'll square that. I'll get negative 3/4 times 4 plus 6. I get negative 3 plus 6. You'll find out, as the book says, k equals 3. So my function now will have to be f of x has to equal now 3 over x, and they will be tangent at the same point, or this line will be tangent at x equals 2. So that's the first problem I was going to solve in class and didn't quite get to. Let's go to the first problem now. find a and b so that f of x is differentiable everywhere. So again, for this to be true, technically by the definition of differentiability, the limit at 2, limit as x approaches 2 from the left, and the difference quotient is at a specific point, so we're going to use the alternate definition of the derivative of f of x minus f of c over x minus c. In this case, 2 is our c value, and I'm approaching it from the left. And that has to be equal to the limit as x approaches 2 from the right of f of x minus f of c, which is 2, over x minus c again, which is 2. Now this is the formal limit definition of the derivative. Now, I solved this problem actually, and I have the paper here, and I actually worked it out this way. And for review, I'll do that here too, but just know that I'll do the quick version over here, and I'll do the actual limit one over on the other side. So let's do the quick version. All this left side is saying right here, I'm going to just highlight it. This left side here is just saying the derivative at 2 of the left side. And now since this is a piecewise function, the left side is going to be the one where x is less than 2. So then f prime of the left would be the derivative of ax to the third. So I'm going to use color coding here. So the derivative of ax to the third, which would be 3, oh, I should use a pen. So it would be 3ax to the second power. Now we'll set that equal now to the derivative of the right side. Okay, so that's this one, and that's f of x as you approach 2 from the right, or numbers bigger than 2. And so that one would be, color code again, as you approach, the derivative then would be 2x. Notice that the derivative of b is just 1. Okay, I'm taking the derivative with respect to x, so b is just a constant. So it's actually be just 0. That's the derivative of b with respect to x, because b is just a constant as far as x is concerned. So now I have this thing, 3ax squared equals 2x, and I just solve for a, because once I have what a is, I'll be able to use it in a different situation. So now what I do is I'll just divide both sides by 3x squared. So I'll do that here. 3x squared, and that's going to get rid of the 3 and the x squared on this side, divided by 3x squared on this side. And now I have this expression for a, and a is going to be equal to 2 over 3 times x. All right, so great, we have what a is supposed to be. Now the other thing that we need to do is then we're going to plug that in for another expression that we need to be true. So not only does the slopes need to be the same, so remember these are slope, so slope at 2 on left has to equal the slope at 2 on the right. We know the slopes have to be equal. We also want the function values to be equal. So we know that ax to the third power itself has to be equal to x squared plus b. Because in order for it to be differentiable, it has to be continuous. And in order for it to be continuous, they have to meet up at that point. Now I know what a is, though. So I can plug in this whole expression down here in for a, up there. And so now I have 2 over 3 times x multiplied by x to the third power equals x squared plus b. And so now I can multiply, so I get 2 thirds, and this x is going to go down by power 1, so 2 thirds x equals x squared plus b. And the convenient part here is now I know what x is supposed to be. This has to happen at x equals 2. That's when they have to have the same values when x is 2. So I can just plug in 2 in for x. So I get 2 thirds, and this is going to be 4. That's what 2 squared is, equals 4 plus b. If I keep going now, 2 thirds of 4, well, I have to multiply 2 times 4, that's 8 thirds. And I'm just going to rewrite 12 as being, I'm going to rewrite 4 as being, let's see here, the denominator is 3, so that's be 12 thirds plus b. Now if I subtract here, you see we get the negative 4 thirds that's in the back of the book. b is negative 4 thirds for that to be true. To find out what a is, we could use a different situation. Well, actually, we don't even need to do that because I know what a is supposed to be. Well, this is supposed to happen, again, at x equals 2. I probably could have said that earlier. I apologize. So a is equal to 3 times 2. So 2 over 3 is 2/6, which is 1/3, which again is what the back of the book is saying. So I found both a and b, so this is true. Again, I apologize for having a complete brain meltdown in the middle of class. Could not remember how to do this, and then I sat down during my prep here, and I was able to figure it out. So I'm going to post this on Schoology. Hopefully you'll be able to see it. and I hope that you have a great evening.